So we're given a reaction. 3 moles of hydrogen plus a mole of nitrogen yields 2 moles of ammonia. And we're given amounts of materials to work with, 1.86 grams of hydrogen and 10.1 grams of nitrogen. So the theoretical yield asks us, given this amount of material, how much ammonia can we create in mass? First thing we need to do is find out what's going to run out first, because that will basically set the parameters for this entire equation. Well, the first thing we need to do is look at the materials we've been given. We only have 1.86 grams of hydrogen and 10.1 grams of nitrogen. Yet in our reaction, for every 3 moles of hydrogen, we need 1 mole of nitrogen. So this shows to me that even though there's a fifth as much hydrogen, we need 3 times as much of it to create ammonia. So that shows me that we're going to run out of hydrogen first. So we need to focus on hydrogen. How much ammonia can you make given 1.86 grams of hydrogen, assuming you will have all the nitrogen you're going to need? So first, we need to find out how many moles of hydrogen we have. So 1.86 grams of hydrogen, the molecule of hydrogen, is roughly the same as saying 1.86 divided by 2. And why is this? Well, the molar mass of hydrogen, the molecule, is 2 grams for every mole. So for 1 mole, we need 2 grams, but we don't have 2 grams, we have 1.86 grams. So we divide this by 2 to find out how many moles we actually have, which we find out is actually 0.93 moles, which is what you would suspect, because 1.86 is almost 2. It's 93% of the way to 2 grams, but it's not quite there, so it's 0.93 moles. So we know how many moles of hydrogen we have, but given how many moles of hydrogen, how many moles, and therefore how many grams, of ammonia can we make? Well, we know that for every 3 moles of hydrogen, we're going to make 2 moles of ammonia. So that's a pretty good ratio. So 2 divided by 3, because for every 2 of this, we need 3 of this. So 2 divided by 3 is 2/3, or 0.66. So knowing that we have 0.93 moles of hydrogen, and 2/3 of that is the amount of moles of ammonia, we simply multiply 0.93 times 2/3, which is 0.66, and that tells us the moles of ammonia, which is some number of moles. I think it's 0.6. So 0.6138, I think, moles of ammonia, which if you use the molar mass, which tells you how many moles per gram, you find that that is the same as 10.5 grams of ammonia. So there you go. You need to find what is the limiting reagent, then find how many moles of that limiting reagent you have, then multiply that amount of moles by the ratio of moles to get your product. Then, using the molar amount of that product times its molar mass, you find the amount of the thing you can create if you have a perfect reaction. So now, knowing our theoretical yield, let's calculate our percent yield. Percent yield tells you, based on how much you should produce versus how much you actually did produce, how good did you do, basically. It's like a grade for chemical production. So last time we produced, theoretically, 10.5 grams of ammonia. And then when we go into the lab, that's not ammonia, that's ammonium. Then when we go into the lab and we decide to try this chemical process for ourselves, we end up only making 2.28 grams of ammonia. A very disappointingly small quantity compared to what we could get theoretically. We had a very inefficient reaction. So how do we find the percent yield of that? Well, all we do is we take the amount we were the amount we actually produced, 2.28, and we divide it by 10.5. Any of you who calculate your grades might be familiar with this, because you're just finding basically the grade of what you did. Assuming 10.5 is 100% A, and 2.28 is the F you got on whatever test you just took, divide your grade by the maximum, and that tells you your percent yield, which in this case is a extremely low 21.7%. Now, these actually give you a decimal, 0.271 ... and you just multiply that decimal by 100 to find your percent yield, which is 21.7. F. You failed at producing ammonia.